So, good afternoon. Thank you very much for joining. I'm going to jump right into it. So, at NavVis, we provide best-in-class reality capture technology. And I think we all know that reality capture doesn't end at capturing. There's several steps we need to take from the end of scanning through to being able to derive usable insights from this data. And thanks to the many leaps in technology we're experiencing today, we're able to do things and solve problems in data synchronization and data registration previously not thought possible. Today, after a quick intro, I'm going to walk you through 3 examples of how NavVis is doing just that. So, unprecedented times. I feel like during COVID, this expression really tripled in popularity. And if you look now at the overall geopolitical situation, they continue to be unprecedented times. And often that's said with a sense of worry or fear about the changing environment around us. We're also facing unprecedented times in terms of technological advances. And this means unprecedented can also be positive, and actually an amazing opportunity to solve problems in a different way. The rapid development of transformational technologies, be it artificial intelligence, machine learning, compute power, have changed the way we can do things in the reality capture industry. Reality capture is becoming faster, more accurate, and less expensive thanks to all these changes in technology. One example alone, data. I don't even pretend to know how much data is out there in the reality capture industry, but I do know how much data we're going through at NavVis. In the last 2 years alone, we've gone through 5.5 petabytes of data in our NavVis processing. And at any given time, we have more than 400 terabytes of scan data in NavVis IVION being used across our global customer base. How are we able to compute, churn, visualize this amount of data? It's all thanks to technology. I remember actually 6 years ago, I was here at INTERGEO when we launched our NavVis Cloud. And I spent basically the whole week convincing people about the cloud. There was still a lot of hesitation about how the cloud plays into the reality capture industry. Now, given the amount of data we have, the amount of power we need to compute through it, and the smart decisions we want to make from it, the cloud is an afterthought and something we need in order to do this the same way all the advances in technology we're seeing today will soon be just part of the daily business. At NavVis, we cover the full value chain for reality capture. So, from capturing with our LX series, to cloud processing with our NavVis IVION processing, through to accessing and utilizing the data, the reason you scanned to begin with, in NavVis IVION, to integrating with third-party software to have an end-to-end workflow. We believe across this entire value chain, in order to continue being successful, we need to embrace all these changes in technology and continue innovating. Customers count on us not just for advanced hardware, but for software that delivers lasting value. We know that reality capture is going from being 3D documentation to the foundation for how the world is viewed, operated, and experienced. And because of that, users demand smarter automation, cleaner data, and more immersive visualization. Ideally, all with the shortest time from capture through to usable data. But as I mentioned, capture is not the end of the story. So buildings are complex. Most often, they need more than one data set in order to be complete. And once you have multiple data sets, this means alignment, registration, management of this data. A process that's time-consuming and error-prone. And all this before you're actually getting any value from your scan data. I'll now share with you 3 ways that at NavVis, we're innovating in order to improve this cycle of getting your data as fast as possible. How we're working to revolutionize data registration and synchronization is through cross-dataset alignment, 360-degree capture, and hide overlap. First, cross-dataset alignment. I'm going to start each of these with a little intro to the actual problem space to make sure we all are aligned on what we're trying to solve. And here, we know that with multiple data sets, it can be both costly and cumbersome to set up control, and as well, in order to do manual alignment, it's very error-prone and also takes a lot of time. The results of the alignment end up either being expensive or inaccurate. Maybe an example. So every scan has a small margin of error. So for example, in this test data set, you can see at the end, there's a little bit of drift coming out. Once that's combined with another data set that also has a little bit of drift, you then have a problem already when you try to align them. Cloud-to-cloud alignment forces the point clouds together and aligns them to minimize the gaps, but it never fits perfectly. You see, by minimizing the gap, the outsides end up being a little bit misaligned. NavVis Cross-Dataset Alignment works differently. Taking the same two data sets, instead of forcing the point clouds together, we're registering them at the SLAM level during processing for a perfect fit. I'll show that example again quickly before I go even deeper into how. So here, you've got the two data sets. Cloud to cloud fits them together, but you still end up with a margin of error by doing it. Cross-dataset alignment, which is done at the SLAM level during processing, provides a fully aligned set of data. So obviously, this was a kind of sample here. Why don't we show the real data? So here are two examples of how this looks with actual scan data from NavVis. So the before on the left, and then with cross-dataset alignment in the after on the right. You can see in the before, the double line going down through and creating a very clear sense that there are two things not perfectly aligned, whereas the after is one clear, crisp line. Looking at walls. Double walls are a standard problem you see within aligning data. On the left, you have both the blue and the orange, whereas on the right, it's one clear line and one clear wall. Bringing them together, you can see in the after both the height, if you look at the stairwell and the floor, as well as the walls, create a single alignment point, which then can be used to have more accurate drawings, take more accurate measurements, and have a really accurate sense of the truth. The result of cross-dataset alignment is fewer projects needing control and overall higher accuracy and reliability. Cross-dataset alignment helps you save effort by aligning datasets in one go, saves time and money by reducing reliance on measured control points, and improves accuracy and reduces drift compared to cloud-to-cloud or manual alignment. And we're thankful to be building this feature alongside some of our customers, and they also find that automating data alignment is really important and valuable time for us to do. Here's a nice quote that shares that. That was cross-dataset alignment. Now, 360-degree capture. So, 360 cameras are often the fastest and easiest way to do visual tracking, either on a project or construction site, or to fill in areas where your scanning device might not fit easily. But the resulting panoramic imagery often ends up across scattered tools and away from your measured scan data. This breaks the workflow, makes it harder to keep all stakeholders aligned, and limits the value of this visual documentation. Here's a quick video of how 360 capture works. First, you'd go in and scan or rescan with your NavVis MLX. Then, you can send in someone with a 360 camera. You don't need to send the scan crew back out if there's an area that needs some additional imagery. Go in with any kind of standard 360 camera. You're able to take images in spots that maybe are not reachable with your device. Then it's as simple as going back to the office, uploading those JPEGs right into NavVis IVION, And we automatically position these images in your site into the right location. From there, you get the fully immersive experience of IVION to walk through side by side your 360-degree images with your images captured during scanning. So, I said we automatically align them. Sounds crazy, but true. The 360 capture feature is built upon our patented visual positioning technology. We use machine learning with a sophisticated neural network to take imagery from your scans and then place additional images with 3-centimeter accuracy as it relates to where they belong in the scan location. To calculate the location of an image, we use AI to identify key visual points in the captured image and then match them to the identical points in the reference scan. You can see here in this image, these are all the points we use to then be able to automatically place these additional images against the measured scan data. In the past, 360-degree images would sit somewhere in folders or file shares, which might be fine for storage, but doesn't add a lot of value. With 360-degree capture, you can import and automatically position your 360-degree images into the exact location in your site. And this gives one central location for all your spatial data. All right, last but certainly not least, hide overlap. Scanning large environments requires multiple data sets, and these data sets have overlap. This is part of the process that you need to do to have full coverage. But overlap creates problems. Redundant data points can cause ghosting, spray noise, blurry surfaces, and they reduce clarity and usability of the data. Manual cleanup is slow, inconsistent, and error-prone. Hide overlap automatically reduces the noise for you. It is a new, unique tool that we're offering that doesn't exist, as we know, in any other tool right now. And how does it work? Hide overlap automatically hides any of the overlapping points in an area that aren't of the best quality. We go through your site, voxel by voxel, looking at which data sets compete in that given area and determine what ones actually have the best quality. In areas that there's potentially too sparse data sets, we may pick multiple data sets, but generally we try to pick one winning data set in every given voxel for the entire site. This results in a very clean and noise-free point cloud experience. Additionally, we're able to use this technology to enable partial rescans. So today, if you're going in to do a rescan, often you'd rescan the entire data set in order to just make it easy. I have this whole data set, let me just plug and play, even though that whole area might not have changed, just a piece of it. With hide overlap, you're able to go in, just scan what has changed, and then drop that data set right in. Hide overlap takes a look to understand both the quality of this incoming data, as well as the date as it references to other data that's already in the site. So for data that is equal or better than past data, we then will put in the new data automatically, being able to really facilitate quick partial rescans and make sure your scan data is reliable and up to date for all your end users. To some examples. So, same model as before. So on the left is the before. You can see kind of a big rainbow hot mess here. And then the one on the right is a much cleaner version. You see especially in the stairwell, which is the purple, it cleans up all the other data sets that were spraying into it previously. Another example here, you can see both the green and the pink were taken in the same areas, but clearly the pink is of a better quality, especially in the corridor, whereas the green on the top side and the pink and the green have a mix down below, but creating a much cleaner picture of how the data interacts. Both of those examples are in single color, so they give kind of a flavor of how it's going, but the real question is, how does this look in reality? We think pretty good. It goes from something that is illegible to being able to read and understand the sign in space there. Also, you can see some of the reflection and ghosting artifacts coming off are cleaned up and replaced by the data set that actually comes at it from the correct angle and doesn't have this extra noise. A classic example, one data set per floor, but with open stairwells, the data sets then bleed into each other. On the left, you see the yellow data set, which is the floor above, peeking down into the red one. After hide overlap, you can see only red, just the points that were meant to be scanned from the area that they were. An example looking to rescanning. On the left, we have a data set from 2021, right from 2023. It's the same area. There's been no structural changes to this space, but there's a lot of mobile furniture, different modules and tables moving around. So when you put them together, it creates a really messy scene. It's hard to tell what's the most newest, what's up to date, and make decisions based on how it's set up. Hide overlap, looking at both date as well as quality, cleans it to only show the newer data in the pink here. In full color, you can see, especially if you look over by the windows where the bigger furniture modules have moved and there was previously a kind of a table merged into it, you can see clearly now there's now a table, there's only one module, and it gives a much cleaner end output and reduces this overlap between different data. So, hide overlap doesn't just save time doing manual cleanup. It gives the best quality data from the start and improves the entire rescanning workflow. So that was a quick overview of cross-dataset alignment, 360-degree capture, and hide overlap. As you can see, we're using advanced technology to improve data alignment, data registration, and data visualization. And that's all with the goal at NavVis to build better reality.